Hi everyone, welcome to this very interesting class on natural language processing where we are going to look at some very core concepts of NLP. We'll be looking at things like how do you do this text normalization of sentences, what is the meaning of stemming, lemmatization, doing sentence segmentation, all these interesting terminologies of NLP which are being used by pretty much any natural language processing project, right? Whether it is Alexa, Siri, Google is using it, ChatGPT, all these concepts are being used all the time. And I'm going to make these concepts crystal clear with very, very simple examples. So let's begin. Before we get started, just a quick reminder, do check out the other courses on our website, manochaacademy.com, and our Android app, Manocha Academy. All the links are given below. As you know, we have courses on physics, chemistry, biology, maths, coding, and artificial intelligence. In our courses, you're going to get live classes, concept videos, quizzes, questions, mock tests, and revision notes. So guys, do check it out. Links are given below. And please do share it with your friends. Make sure you follow us on YouTube, Facebook, Insta, and X. So stay connected with us and keep learning. So before we look at core concepts of natural language processing, first let's do a quick comparison between the human language versus computer language. Right? Human language means the languages that we speak, right? So we speak or we write, and we have many languages, right? Like so there's English, Hindi, Bengali, Tamil, Telugu, Spanish, German, Japanese, Chinese, so many languages in the world, right? And we are using it as a means of communication between humans. Similarly, in computer, there are many languages, right, that you learn as programming languages, right? For example, we have course on Python, we have course on Java, then there's C++, C#, so many languages. But finally, what does a computer understand, right? Finally, it's all changed into machine language or into binary, okay? But when we talk about computer language, you can think of, we are talking about a programming language, but also understand that finally it is turned into all numbers or code, right? So what are the similarities between human and computer language? So first similarity is that there is a syntax. What do we mean by syntax, guys? Like when you have done programming, you have seen that thing, syntax error, right? There's a syntax error. So syntax basically means a set of rules. Syntax basically, you can remember, is a set of rules, or we can say grammar rules. Okay, so just like when we write a sentence, it has to follow the rules, right? Ajay plays with a ball. Okay, I cannot say Ajay with ball plays, right? That will not be correct. Grammatically, it is incorrect. So this is what the English teachers teach us, right? That you have written this sentence is wrong because it is grammatically incorrect. They're not checking, it's not the spelling error, right? It is first they're checking the grammatical error. Of course, there could be spelling errors also, but we're talking about, does it grammatically, does the, there's the noun, verb, and all, you guys are more expert than me in all those English things, right? So it all has to follow a set of rules, okay? Similarly, in computer language, also there is a set of rules, okay? So for example, when you're writing code in Python, right? Then you write, for example, print A. Now A, it has to be like you have to put it within the bracket. There's a function. Similarly, when you write a code in Java, okay, system.out.println, that's the way to print out stuff. So it is following certain rules. And if you don't go by those rules, the program will not even compile. So this is a clear similarity. Similarly, our English teacher acts as the compiler and they put a cross if you write a wrong sentence which is not syntactically or it is not following the rules. The other thing common is semantics. What is the meaning of semantics? So this, be very clear about this, and I'll show you with an example. Semantics basically refers to the meaning. Syntax is basically referring to the rules. Semantics is what is the meaning, what is the intention of the sentence here. So if you take a look at these two sentences, Ajay plays with a ball and a ball plays with Ajay. Can you tell me that are they following the grammar rules? Are they correct syntax wise? So if you look at these two sentences, the syntax is correct. Okay. So if you look at it in terms of syntax, both the sentences are correct. Then there is no grammar error over here. But if you read the two sentences, do they have the same meaning? Or does the second sentence have any meaning? So if let's use the pink color for semantics. So can you tell me which sentence is semantically correct? Syntactically, both sentences are correct. There's no grammar error. Unless you are more expert at me in English, you can find some grammar error, let me know. But syntax-wise, these are correct. Ajay plays with the ball, a ball plays with Ajay. So meaning-wise, if you read it like as a, as a person who knows English, you will know that Ajay plays with a ball makes sense, right? Ajay is a person here, ball is the object, he's playing with it. A ball plays with Ajay. Ball is not a living thing, right? So a ball playing with Ajay doesn't make sense. Ajay is playing with the ball. So that is why here we say this is right in according to semantics, but this is wrong according to the meaning is wrong here. Okay, so with this example, it is clear what is the difference between syntax and semantics. And this is the similarity of both human and computer language. They both have syntax and they also have semantics. Now in programming language, when you're writing a program like print out or run a for loop, you are having a intention over there. You're conveying a meaning to the compiler. Okay, so you're following rules, plus the compiler is understanding, oh, this guy wants to run a loop. Okay, now he wants to print. Now he wants to break out of the loop. Okay, so those are all the meanings, the semantics. Now, what are the differences between human and computer languages, right? So, of course, when you look up different books, they'll have different things to say. But in the basic differences, one is morphology. Morphology means the human language is very rich, right? We say we have different forms of the word, like we have dog, dogs. Similarly, I'm happy, happiness, right? He plays, played, past tense. So you just don't have these single words. You have the different forms, right? You can have the plural form, the past tense, and all of this. So there are many different. So words have both structure and different forms. So you can see words in different forms. And this is what the linguists or people with the language, they deal with, the morphology of words. Okay, so this is there in human language, but it is not there in computer language. So all these stuff are to deal with the human languages, okay, and absent in computer language. Similarly, when we are telling there's some logic, right, there's some emotion in our talking. Right now, of course, in future, maybe AI will also have emotions, right, and speak, some logical reasoning and all those things. But currently, that is the privilege of the human language, right? So in human language, we say there is logic, there's emotion, which is absent in a computer language. Then you have things like, you have synonym, antonym. So like, for example, if you take the word happy, some synonyms are joyful, merry, blissful, right? Antonyms are opposite of happy, sad, right? Or somebody is morose, and there are many words over there, right? But in computer language, when you're writing a programming language, for example, if you take Java, we write int for integer. Is there any synonym for that? Okay. Or when you have a print statement in Python, is there any synonym? Can we say instead of print, can we write output or display? That will call maybe there's another function like that, but it will not do the job of the print. Okay. There could be some rare cases where this thing, but what we are talking in general, when you have some reserved word, it has only one meaning. Okay. It is not having, you will not have multiple words having the same meaning. So this whole thing of synonym, antonym is only for a computer language. Does that make sense? This is only for a computer language. Again, you can say in human language, errors are allowed. What do I mean by errors are allowed? So suppose, I had written this spelling of, I had written this sentence like this. Okay. Or in allowed, I had missed one L. You would have still got it, right? Errors are allowed. You would have still understood the sentence. Or many times when we speak, sometimes we laugh at our friend, right? Oh, he's telling some wrong English, or he's speaking some wrong Hindi, or some wrong Tamil, Telugu, right? Like many times I speak wrong Bengali. I'm not super fluent in Bengali. But the other person listening, they have a laugh, but they understand the meaning. But will a compiler allow that? Is that allowed in computer language? No. It does not pass your this thing. Your program may have a logical error which it may not catch, right? It may be caught during runtime, like we had a class on Python on the types of errors. But here, basically, the errors are absolutely not allowed in a computer program. It will not compile it. It will not pass your program, so it will not convert it into machine language. Okay, so here errors are allowed in a human language. So it is more forgiving, but in computer language, so this is for a human language, errors are okay, but computer language, absolutely not allowed. Okay, so this all simple stuff makes sense. And then there is the context, right? So what does the word context mean to you guys? So context means words having a different meaning, right? Like for example, if we take Virat plays cricket with a cricket bat, okay? Or you may say that, a bat was flying in the sky. Does it mean the same cricket bat as Virat's? When I'm saying, so suppose I'm telling you that, Virat was playing cricket with the cricket bat. And then I say, and then I saw a bat flying in the sky. The two bats are different here. Cricket bat, the cricket bat I'm talking about. And bat means the mammal, the animal, right? Which flies at night. So that's why many things, there are double meaning, but we understand from the context. So this is there in human language where there is ambiguity, but because we are intelligent people, right? We know the context. But in computer language, when we have designed it without any ambiguity, right? It is very clear. If it is this, do this. If it is that, do that. Okay. AI may be able to handle ambiguity and all, but here when we are talking about computer language, the normal programming language that you follow, which is finally converted to machine language. Okay. Machine language means binary, right? Ones and zeros. So context is again for human language. Okay, I hope all these points are clear to you. Now let's come to the very interesting concepts of NLP. Okay, and NLP, natural language processing, as you can expect, like ChatGPT, of course, there's a speech and all, right? But it's basically handling lots of text, right? It's all text based. Like your chatbot, you have seen the ChatGPT is text based. You've given some text input, it replies to you in text, right? Or if you're using Alexa or Siri, you're using speech, but that speech is finally being converted to text. It processes that text and gives an output where again it converts it to text and then speaks it out. Okay, so the NLP is all about text handling, right? It's all about text, and text, right? So NLP is, you can think, lots of text. And you can imagine this ChatGPT, and as we have discussed in our earlier classes, all these chatbots, they are trained on tremendous amount of text data, right? So you can imagine the ChatGPT is trained on billions and millions of text data, books, articles, internet stuff, so much knowledge it has, right? So it is definitely handling a huge amount of text. So this is where this text normalization becomes very important, because how is ChatGPT or all this designed? We know that they are basically designed on a very smart AI model, which is basically a neural network. And so to train this neural network, you've given a bunch of text, right? So you give it lots of text. So if you take again the chatbot example, let's say like we said, if you want to make a chatbot for vacation planning or whatever, you'll give it a lot of vacation planning text. You want to make a science encyclopedia, science chatbot, you'll give it a lot of science text, right? So a lot of text has to be input into the neural network. Now, will you just take the raw text and put it? No, because I told you this whole AI field is all play of data, which is why data scientist is becoming the #1 job today. It's all a play of data, and data has to be good data, right? We want to feed in the relevant good data. And this is where text normalization is super important, because it has only one goal: to simplify the text for processing, right? For processing, to input it for training, testing, whatever you can call it, right? So the goal is to simplify the text that is input into these models, right? Or for processing. Now, what is there in text normalization? Text normalization, there are many steps. It's not just one magic thing. You can do sentence segmentation, tokenization, removing stop words, special characters, handling your numbers, stemming, lemmatization, case normalization. You'll say, oh my God, don't worry. We are going to go through all these 7 concepts of text normalization, or you can say concepts of natural language processing, because see, finally you're processing the text that we are going to use either to train the model or use to test something, whatever be the goal there. But we are going to understand today how to do text processing, and this text processing is known as text normalization. You're like normalizing or simplifying the text. So the first step in text normalization, we said the first step is sentence segmentation. This is pretty easy. Like if I give you a bunch of text, like a storybook or a bunch of text like this, sentence segmentation basically says break down the text, all the text that is given into smaller parts. And what do we mean by smaller parts? Basically into individual sentences. So like the English language is constructed like that, everything we break out down into individual sentence, and we usually end with a full stop or a question mark or something, right? Some punctuation. So for example, if I give you this text, so suppose you have this text, the cat jumped over the fence. The dog, the rat, the mouse, etc. ran after the cat. The cat jumped on the rat. The rat gave the cat $6.5. What happened after that? Let me know. So you can see this is a bunch of text. So all of you can see that here we have been given a bunch of text. And our first job is to break down this text into segments, into individual parts, into sentences. So can you guys tell me how many sentences there are? So you'd say that's very easy. The cat jumped over the fence. This is the first sentence. So this is segment number 1. Then you can say the dog, the rat. So should I break it down by full stop or comma? Should I break it down with the comma? No, full stop, because the dog, the rat won't make correct sentences. So I'll include everything. The dog, the rat, the mouse, etc. So see, this is a little dangerous. You can see there is a dot over there. If I break it down over there, then the sentence will not have the correct meaning. So we have to be very careful over here. Can you see? We have to be very careful. And this is where we'll have to have some special cases. If we see etc dot, we have to remove the dot over here. So basically, you have to get rid of this dot. Can you see that? So this is a very special case over here. Okay. So we have to get rid of that dot and ran after the cat. So this is where my second sentence ends. Clear? Then the next sentence will be the cat jumped on the rat. That's clear. So this is my next segment, segment number 3. And then the rat gave the cat $6.5. See, again, there is a dot over here. Now, if you break it here, it will not be correct. So numbers, again, we'll have to handle. Okay, we'll have to look at these dots. So this is again an exceptional case. So this, when we are doing programming, this is where, the programmers, they have to handle all this stuff. So this is my 4th sentence. What happened after that? Sentence may end with a question mark, need not be a full stop always. So this is another segment. Let me know. So do you guys agree? We have total 6 segments over here. This is the meaning of sentence segmentation. Breaking it down, and we are breaking it down using punctuation. So breaking using punctuation, not just the full stops. It could be question mark, exclamation. So this is where you have to handle it, right? This is where just a simple dot breaking will not work. So like if you're running, a breakdown in a Python, say split this text according to dot, it will cause some problems. So we are done with the first step, sentence segmentation. So this step is done, which means basically breaking it down into sentences. Next, let's go for tokenization. So once the sentence has been broken down, you split the sentence into smaller units, what we call as tokens. So the second step is splitting your sentence into small units called tokens. Token word we have used in programming also, right? Every word of a program we call as token. So tokens, they can be words. The simplest one is word. It could also sometimes be a phrase or a number or some symbols. Okay. So let's say I give you this sentence. The cat jumped on the rat. And I say, hey, break it into the tokens. So you'll break it like this, right? So the is one token, cat jumped on the rat. And let's say we throw away the dot. Can you see the tokens? Same way here. The rat gave the cat. And see, this whole $6.5 is one number. What happened? So can you guys see? These are, each individual word is basically a token. So token could be a word, it could be a number, sometimes it can be some special symbols also. Maybe you broke it like this. Could be your logic. So see, again, there is no one perfect logic here. This also depends on the project. Let's say it's a currency project, and getting that currency out is very important for you. Okay, because dollars, it really means $6.5 or $6.5. So guys, we're done with the first two steps: sentence segmentation, break it in text into sentences, and then break the sentences into words. Because here the output is sentences. Here the output, you can think words, phrases. So just for simplicity, I'll write words. Now, what is the next step? Removing stop words and special characters. So this is a very important step, which you can imagine Google, Chat, GPT, they're doing this, that they are removing words and they want to remove these stop words. What is the meaning of stop words? They are words in the language which do not add much meaning to the sentence. So you can remove them without much affecting the meaning. So let's try an example. And the famous stop words in English, the common ones are a and the. See, these are very common words, but they don't have much meaning, right? Or even the word, we can add to that one more and the, right? So we can add another one here. These are all stop words. So for example, if you have a sentence, the cat jumped on a rat. So here, what will we do? I want to remove the stop words. So I'll say, let's remove the, let's remove a, and we said we will also remove all these special characters. Because sometimes, when ChatGPT and all is taking text, it's taking text from books, internet, scanned data so much, it could have some garbage characters also, or some special characters which may have meaning, may not, but not for this project. So I'll say, let's get rid of all this. Now, guys, if you read this sentence, so read this sentence for me. Cat jumped on rat. Is the meaning conveyed to you? Even after removing the stop words, is the meaning any different? So you can imagine when you're doing a Google search, and if you write, you are looking for, let's say you're looking, let's say I want to search for a coat, the best coat in Kolkata, or the best coat shop in Kolkata, the is gone. Or if you say, I want to buy a trousers or a shirt, a is gone. Google doesn't care about a, right? Same with the, it doesn't care about. So this is the removing stop words, but you can see the meaning is still there. Same way, look at that last sentence. The cat ran after a rat and a mouse. But here you could debate a little bit. Cat ran after rat mouse. So and maybe is important here, may not be. But again, see, if you read this thing, you're still getting the picture. Cat ran after rat mouse. It's very clear. Now, why are they doing this? We are doing this one. So this part, one advantage is this is for cleanup. So removing special characters, you can think, is for cleanup. Because we don't want to train, let's say again, our goal, always think our goal is to train a chatbot, right? Or to train a chat GPT. We don't want to give it garbage data and spoil the model, right? Because that will make it bad. So the advantages here, we can say, of doing this step is one is simple cleanup. Second is reducing the size of the data. Okay, you're throwing away some useless words or stop words which don't have much meaning, right? So you can say that you're reducing the data size. When you reduce the data size, obviously the training will be faster. It will be more efficient, right? So we can say training, testing will be faster. It's going to be more efficient. Make sense? And what do you think? Will the model be better or not? Will the quality of the model be better? Yes, because you have thrown away the irrelevant stuff, right? Because you're removing the irrelevant stuff. So we can imagine we'll get a better AI model, better NLP model here, definitely. So this is the goal of this step. Exactly, very good example that ChatGPT is also doing this. When you type in a question, do you think it is taking all your the? No, it's throwing all that away. It just wants the meaning. So definitely ChatGPT, Google, Gemini, they're all doing this. So clear? So this is more of the cleanup and better training. Everyone is clear what is the goal of here. Next one is called handling numbers, right? Because there you saw there can be some numbers in the text. Now how do we handle them? So basically, numbers, if they're just like, digit, so either the model you could be handling numbers, or maybe you want to convert the numbers to words. So again, it depends on your project. And note one thing, you don't have to do every step. Okay. Maybe you don't want to remove those stop words. Maybe your project is very simple, doesn't matter, right? But in a real large scale, huge model, you can imagine it will give a huge gain, right? It's a big advantage. Same way over here. Let's say the cat gave the rat gave the cat $6.5 so that the cat doesn't eat it up. He's basically bribing the cat. So here you can imagine, what will you convert this? You want to normalize this. So maybe you will have a program which will change this into $6.5. And definitely you can imagine this is being done for a text to speech system. When the thing speaks back, if it gets $6.5, it has to do this, right? It has to convert it into $6.5. Or maybe in your system, you didn't do this. Another option is you did this, $6.50. So that dollar symbol you converted, right? Or $6.5. Are you guys getting the meaning? Same way over here, 12 apples. So this 12 you converted into the English, the full word. Okay. So that you can relate it to a dozen, right? It can have a meaning. It's not just a number. And here this you converted into 60 rupees. Or maybe you're very specific and you say 0 paise also. I don't know. So here basically what you're doing, you're changing your words, you're changing your numbers to words. So the goal over here is converting numbers to words so that it all becomes text, right? It all becomes the same kind of text. We are not having a text and numbers. Everything is now in the form of text. So we have handled the numbers also. Now let's come to these really interesting steps, which are stemming and lemmatization. Really fun stuff. What is the process of stemming? In stemming, what are you doing? You want to extract the root form. This again might remind you of all your English grammar classes. What is the root form of the word? Simply by removing the affixes. So here we do it in a very simple way, right? We don't do like an English teacher. So I'll show you. Like let's take an example. So if I say this is the word is cats, and I tell you what is the root word. So like the English teacher will say, remove the plural s. So we'll do that. Okay, we'll say done. So the stem, the stem of this word. So that is why we use this word stem. The stem of this word. So let's write the heading here, stems. The stem of the word cats is simply the word cat. You have removed the plural. Can you tell me what is the stem of dog? Can you guys tell me what is the stem of dog? So see, in dog, the root form is dog. So there's no dogs or, something like doggy, where you could remove the GY or something, right? So it's all dog. So that's fine. So the stem could be the same as the word. So this example is teaching you, it need not be different. Now for running, can you tell me what is the stem? So see, we will throw the NING part. We can say simply the root word is stem, is run. For happiness, can you tell me what is the stem word? So this one, running, run is clear. Happiness, can you guys tell me? So in stemming, you are extracting the root form simply by removing. So note here one interesting thing. You are just doing a removal. Like S we have removed. Dog, there's nothing to remove. Here, what did we remove? NING. In happiness, similarly, what will you remove? You will remove ness. So what will be left? The answer is happy, and you're not allowed to change. But you'll say, hey, this is not meaningful. That is why we will come to lemmatization. That is the next step. So you'll just, stemming means just throw away the ness. So see, even a computer, you can understand, okay, happy, okay, with a misspelling, right? But the root, you have caught the root here, even though it's not a meaningful word. So now guys, can you tell me for studies, what will be the stem word? Come on. Apply this rule here for studies. So remember, you can only delete stuff. So what will you delete? So ES we will delete. I we cannot delete. It will not be stud. It will be study with a I. Very, very important step. So see, basically we are extracting the root meaning from each word. Happiness means, if because a person can say I'm happy or I'm in happiness, he's meaning the same thing, right? I'm He's doing his studies, he's studying, he's go and sit and study, all mean the same thing. So you're basically extracting the meaning here. Clear? So very, very interesting. So these are all made by the computer scientists, right? When they studied NLP, computer scientists, linguists, they have all made these techniques and they're being used right now. Okay, they are all in action in all your Google, ChatGPT, everywhere, Bing, everyone is using all this stuff, right? Okay, or your, Grammarly, giving you grammar suggestions, all using this stuff. So this step has also happened where basically you have extracted the root. Okay, so number handling has happened, and as a result of stemming, we have basically got the root. But we have not got the proper root word. So that is the job of lemmatization. So after stemming comes lemmatization, the process of converting the word, right, to its actual root form, right? So whatever output you got from stemming, you are giving the actual root form, the word that actually exists in the language. So basically not a fake word, because stemming could give a fake word, right, or a word which doesn't exist, and this we call as lemmas. Okay, so let's take a look at example here. So we will do the two steps. So first step, we'll always, typically it goes through, the word goes through stemming, then through lemmatization. Okay, so here we can say what is the stem of it, and then what is the lemma of it. See, they are called lemmas. So let's put the heading lemma. Okay, ready? Let's do this together. So for cats, what was the stem? Remove the S, remember? Remove the S, it is cat. What is the lemma? Cat is already meaningful, so no problem there. The lemma is cat. The root is cat. Running, what is the job there? We said ring will delete off. So the stem is run. And the lemma also will be, it's a meaningful word, right? The lemma is run. Now maybe some lemmas will change it to ran, right? Run, but ran is a past form. So this is a correct form, looks like it's fine. So again, it depends on your logic, right? So here, happiness. So we said we'll remove the ness and we'll make it happy with the I. What will be the lemma of it? Here you will put in the Y, because it has to be the real word in the dictionary, in the English language, right? So happy with Y. Now studies, can you guys do it? Studies, delete the ES, sorry. So you'll get study with the I, and here you will get study with the Y. Make sense? Troubles. What will you do for troubles? You'll say the ES goes away, because we remove the S, right? And we remove the E also, let's say. Again, it depends on the logic, because ES is many plural. So the stem could be trouble without the E. But in lemma, what will you do? You will basically add the E. So lemma will become trouble with the proper E there. So can you see you have got all this is the sort of, you're trying to get to the root word, and here you have got to the actual root form. That is the meaning of lemmatization. I hope I got the spelling correct. Sometimes you might see it with a Z also, American spelling. So this is the meaning of converting the word into the root form. And you can see the goal here is to get to what is the meaning of it, right? Because of this whole thing, right? In English is a very, human language is a very rich language, right? There's a present tense, there's a past tense, there's a future tense. So all this thing, you just want to get the meaning, right? You don't want all these forms to trouble your model. So see, we have done all these initial steps, and last we are left with a very easy step, which is called case normalization. Okay, case normalization is very easy. So let's say you have done this, I'll ask you one question later. First, let's discuss this case normalization. So the process of converting all the words, so all the words that you've got, you're converting it to the same case. And usually we convert it to lowercase. So for example, after all those, steps that you did, you got the sentence, cat jumped over the fence. So here this is pretty simple. We will basically convert this sentence entire sentence into lowercase. Cat jumped over fence. So see, all my stop words, everything are removed. Everything in lowercase. Same way, dog ran after mouse. Dog, everything to lowercase. See, MO is capital, no, mouse. So this is basically like running the two lowercase function, right? Or two uppercase. Generally, we do two lowercase. Again, what is the goal? To make everything, all the words similar, right? So there should be all these capitalizations and all those things should not make the words different to get them to the same base. Okay, so that's pretty easy. So that the model takes everything in lowercase. Now, one question that's what I said, that why don't we do this simple step right at the beginning? Many times when we write computer programming, the first step we do that. But in many, so that could be done as a first step also. But in many projects, this is done as the last step. Can you tell me why? See, because let's say in the beginning, the sentence had the word capital AI and it had some small AI also. Maybe then, let's say English had a word of A, the small AI also has some meaning, capital AI has some meaning. So there, the capitalization may be important. So there maybe we want to normalize this into artificial intelligence. Okay, then we want to apply the this case normalization. So maybe before, when you're doing all those special handling or special handling of numbers or on that time small and big might be important for you. Okay, so there are many cases where capital is conveying some meaning, like this is an abbreviation. Okay, this might be saying like someone, you're calling someone I, right, or something like that. I'm just giving you an example, but this is AI is for artificial intelligence. Okay, or I don't know if you guys can give me some other example, like if you take suppose add, ADD. Normally we say this is addition, add, but ADD could be the name of a company or the name of a band or something like that, right? So capital might have meaning there, and then you want to convert it into, right? That ADD actually means maybe something, right? It stands for something over here. So there maybe you want to add some A dot T dot D dot. So these all special cases you can do, provided you have not lost the case. So that's why when you want to convert everything into lowercase, that is typically done as the last step. And definitely Google Chat GPT, they're doing it because they don't care what case you type in. They may care for those special cases, right? Like those abbreviations and all. But at the end, once it's it's taking all your data, it throws away all that case knowledge. So here we have done very, very important concepts of NLP, which is basically the goal. The goal is text normalization. So you can see the entire goal over here is to normalize the text, which means simplify, like simplify your life, simplify all the text so that it is suitable for processing, right? Suitable for training data or as test data or whatever, right? So here, this is what we have learned today. So let's summarize what we have learned. First one is breaking the sentences, right? Sentence segmentation is basically you take your text, so you're going from text to sentences, splitting it into sentences. In the next step, tokenization, you're basically going down to the word level. You're going down to the word level. Then removing stop words, special characters and all this I consider as your cleanup stage, right? Because the text could have some garbage characters and all that, special characters, or you can call them garbage characters. Handling numbers, right? So converting numbers. So here the goal was numbers to text or numbers to words. Again, for every project, you don't have to do everything. Some could be optional, right? So stemming here, to get to the root. Okay, lemmatization, real root word. So to get to the real root word. And the last one is very easy. Convert everything to, let's say we want to convert everything to lowercase. So these are the core, very important concepts of NLP related to text normalization. So whenever you're doing a project, right, if you're doing some NLP project, you want some data, you have to run through at least some of these steps, if not all. Okay, maybe in your steps you could avoid. Okay, you don't want to do stem or lemmatization, right? So we'll be looking at all this stuff in our projects, right? So stemming, lemmatization, maybe you want to skip that. You want to deal just with this stuff, or maybe you don't want to handle numbers. That depends on your project, right? On your goals. Okay, but these are the very important concepts of NLP which are used for text normalization. And again, remember the goal: simplify all your text. So see, in lowercase, we could have a very good example, like if you take the word add, this might mean a date, right? AD. So for example, some date, that Anno Domini, right, what you've learned in history. But if you convert that to small AD, it means an advertisement. So that is where the capital thing may be important for you, especially if you're doing a history project. So these are also, text is very tricky. It's very tricky job. That's why all these have been developed over the years, and they're still improving all this, right? This is just work in progress, right? So hope you guys enjoyed this class where we did some very important concepts of NLP related to text normalization. Hope you guys understood these concepts well with all the simple examples that we discussed. And do check out the other courses on our website, manochaacademy.com, and our Android app, Manocha Academy. All the links are given below. As you know, we have courses on physics, chemistry, biology, maths, coding, and artificial intelligence. In our courses, you're going to get concept videos, live classes, quizzes, questions, mock test, and revision notes. So they're going to be perfect for your exam preparation. So do check out the links given below. Share it with your friends. Make sure you have subscribed to our YouTube channel. You can follow us on Facebook, Insta, and X. So stay connected with Manocha Academy and just keep on learning.